Okay, next we're going to talk about estimating products that have decimals as factors. Now we're going to start off with an easy one that should look somewhat familiar, and will kind of ease you into the process here. So we have $2.15 times 16. Now normally when you see a problem like this, you would get out your calculator, you type it in, and you get your answer. But let's talk about how we can estimate our product here. $2.15 would round down to $2, and we could round $16 up to $20. That makes it a lot easier. So 2 times 20 will give us $40. That's a very simple example. But what happens when you have to estimate one of the factors that's less than 1? What can we do? So let's look at this. We have 184 times 75 hundredths. When we look at this problem, yeah, we could round the 75 hundredths up, and we could say, oh, 184 times 1 is 184. But the problem is we'd always do that. You know, whether it's 6/10, 9/10, 75 hundredths, 84 hundredths, we'd always round up to 1. And that's not going to give us a solid answer. So what can we do? Well, first of all, let's take care of that 184, and let's make that an even 200. That makes it a little bit easier to work with. Now, we have to round our 75 hundredths that 5 tells us to round up the 7 up to 8. So now we have 200 times 8/10. So what I'm going to do, and you probably have seen this before, I'm going to underline my non-zero digits, 2 and 8. I'm going to take that 2 times the 8. I'm going to get 16. Now, listen carefully. I want to put all my zeros that are not just in front of a decimal. For instance, that 0 in front of 0.8, that really has no meaning or value to it. The 0 after the 2 and 200, both of them have value because they're placeholders. So I'm going to drag both those zeros over, and I get 1,600. Here's the last step, and here is how it's different. How many digits are behind the decimal place in this? Well, let's look. For 200, there are no digits behind a decimal. In 0.8, there is 1, the 8. So in our answer, we need 1 digit behind the decimal. So I start behind my number, and I move to the left 1 place. I put it between the 2 zeros. So my actual answer is 160. Let's look at another example. 0 and 667 thousandths times 4. Well, 667 thousandths we can round to 7/10. So now we have 7/10 times 4. I underline my non-zero digits. 7 times 4 is 28. Let's go back and count our digits behind the decimal. 7.7 has 1 digit. 4 does not have any, so we need 1 digit behind the decimal. So therefore, we start behind the 8, we move 1 place, and we put it between the 2 and the 8. The last example is 87 hundredths times 412. Now, with this, we have we can round the 87 hundredths up to 9/10. And we round that 412 down to 400. So now we underline our non-zero digits, the 9 and the 4. 9 times 4 is 36. Now we need all vital and important zeros to come down. Those are the zeros in the 400. So we bring down those 2 zeros. So now we get 3,600. The problem is we have 1 digit behind the decimal, that 9. Therefore, we need 1 digit behind the decimal in our answer. So we start to the right and we work 1 digit over. So our answer, we'll put the decimal between both zeros. So our answer is now 360, not 3,600. And that's how you use compatible numbers and estimating to find about what your product should be with decimals.